Okay. I'm looking at, oh, not this stuff. What is this? What is this? Okay. Okay, perfect. We're doing trigonometry. I'm not crazy about like SOHCAHTOA and stuff like that. It's pretty basic. There's parts of trigonometry that are like probably my favorite high school. Like when I went to high school, my favorite parts of mathematics. But we'll get later on. Later on, we'll get really deep in it and we'll start proving identities. And it gets very challenging. It's, again, probably my favorite part of high school math. If we don't count calculus as high school math, which normally it isn't, but is what it is. All right, find the value of the 6 trigonometric functions for angle theta. This is problem 13, and they give you a triangle, a right triangle that's like flipped over. And this is 12, and this is 13, and we don't have the third side, and here's angle theta. Okay, so the triangle's just kind of rotated. They're trying to make it difficult, but it's not that bad. So we want to find the 6 trigonometric functions: sine theta, cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta. Natalie's not here. Finding these 6 trigonometric functions. Before we do this, we need to find this missing side. That actually, if you look at it, you might have to turn your head. That's the adjacent side. So, Pythagorean theorem, I guess I'll call this B or something. I don't know. B. And you'll have B squared plus A squared equals C squared. I don't know if everyone knows this, but this feels like a 5, 12, 13 right triangle, one of our Pythagorean triplets that we're supposed to memorize. Maybe. I don't know. Let's see. B squared equals 169 minus 144. That definitely looks like 25. So you get B squared equals 25. So B equals 5. Now, plus or minus, we're talking about a length of a side of a triangle. So I'm going to throw 5 in here. Let me erase my B. And this length of this side is 5. And now I can answer all the questions. Once I have all 3 sides of the right triangle, then the answers aren't too bad. So sine is opposite over hypotenuse. So I'm going to say 12 over 13. Again, opposite of this angle. Cosine is adjacent. So 5 over 13. Tangent is opposite over adjacent. So 12/5. Double checking my answers here. Yeah, looks good. Cosecant, it's going to be the reciprocal of sine, so 13/12. Secant is the reciprocal of cosine, so 13/5. And then finally cotangent is reciprocal of tangent, so 5/12. Easy enough, not bad. Hopefully this is review, you saw a little bit of it. It's not too bad. It's like that all like SOHCAHTOA thing. All right, 15. Now they give us a triangle that looks like this. Again, like the angle that we're referencing isn't in our like standard position, but that's okay. They give us 10, which is the hypotenuse, of course. It's across from the 90-degree angle. And they give us 7, which is adjacent. Now, I don't remember any Pythagorean triplet that has a 10 and a 7, but I could be wrong. So we're going to figure this out. Got to figure out this side. I'll call it A, maybe. So I got A squared plus 49 equals 100. So I get A squared equals 51. So A is equal to the square root of 51 if I did that correctly. I'm going to double check my answer key. Looks good. All right, so then I got to find sine. So sine theta is going to be the opposite over the hypotenuse. So square root of 51 over 10. Cosine theta is going to be the adjacent over hypotenuse, so 7/10. Tangent theta is going to be opposite over adjacent, so square root of 51 over 7. Let's do our cosecant theta. Cosecant theta is going to be 10 over the square root of 51. If we rationalize that, which we should, this is going to be 10 square root of 51 over 51. No big deal. Secant theta is going to be the reciprocal of cosine, which is 10/7. Cotangent theta is 7 over the square root of 51. It's the reciprocal of tangent. I'm going to rationalize that, and this will be 7 square root of 51 over 51. Easy enough. I feel like I'm going slow. There's like so many questions to answer, like list all 5, list all 17, even on the next one. So 17 says tangent A is equal to 8 over 15. All right, so this is the same type of problem. It says list the other 5 remaining trig functions. So the first thing we have to do is build a right triangle. I'm going to put an angle A there. Here's my right angle. And tangent is opposite over adjacent. So this is 8 over 15. I want to say there's an 8/15 Pythagorean triplet, but I don't remember. Here's our hypotenuse, which we'll call side C. So I'll say 15 squared, which is 225, plus 64 squared is going to be C squared. 289. That sounds like something. 289 is C squared. I believe that's 17. But let's just double check. I don't know for sure. Let's see. 17 times 17. 49. 11. This is looking good. This is 0. This is 17. Look at that, 289. Boom. Yay. C equals 17. Awesome. So C equals 17. So then we answer other values. We're going to find sine of A, cosine of A, tangent we already have, cosecant. Let me scoot this over just a little bit. Cosecant of A, cosecant of A, secant of A, and cotangent of A. So sine is opposite over hypotenuse. So 8/17. Cosine is adjacent over hypotenuse. So 15 over 17. Cosecant is going to be the reciprocal of sine. So 17 over 8. Secant is going to be the reciprocal of cosine. So 17 over 15. And then cotangent is going to be reciprocal of tangent. So 15 over 8. Boom. Boom. Looks good. Looks good. Looks good. Looks good. All right, on to the next one. We're on 19. Tracking along. I'm hoping to get this under 20 minutes, but it doesn't look like it. Tangent. Tangent B is equal to 3. Remember, a trig function is a ratio of 2 sides of a right triangle. So I'm going to rewrite this as 3 over 1. I'm going to draw my triangle. Yep. Here's angle B. Here's a right angle. Tangent is the opposite side to the adjacent side. So this is 3 and 1. And then to find the missing side, just 1 squared plus 3 squared equals c squared. So I got 1 plus 9, which is 10, is equal to c squared. So I believe this is the square root of 10. I can't really do anything with that. Same idea, so I get sine b. Sine b is equal to opposite over hypotenuse. Throw 3 rad 10. Let's go ahead and rationalize that. That's going to be equal to 3 rad 10 over 10. Let's do cosine b. Cosine is adjacent over hypotenuse. So 1 over rad 10, which is rad 10 over 10. Let's do cosecant. Cosecant, I swear that's a C. A B. Well, cosecant is going to be the reciprocal. So we get rad 10 over 3. Looks good. We get secant of B. That's going to be the reciprocal. So you get rad 10 over 1, which is just rad 10. And then finally cotangent of B. That's going to be the reciprocal of tangent, which is just 1/3. That's my answer. On to 21. I got to turn the page in the textbook. Turning the page. Oh, okay, these should go fast. So 21, I don't want to draw these pictures every time, but maybe I will. Here's my right triangle. There's a 9, an X, and 45 degrees. Interesting enough, so you got to figure out what sides we have. Well, this is the hypotenuse. It's across from the 90, and this is opposite. So which trig function uses opposite and hypotenuse? That should be sine. So we'll say sine of 45 degrees is equal to opposite over hypotenuse. I'm going to solve for x. I'll say x times sine of 45 degrees is equal to 9. And so therefore x is equal to 9 over sine of 45 degrees as my answer. I like that answer. I know they have like 12.7 is the answer, but I don't know. It's not. I prefer the exact answer. Let's see if I can pull up a Desmos. Graphing calculator. Whatever. And then I can just throw this in here. X was equal to 12. You can't see, it's off the screen. Sine of 45. Interesting. Let me see what I did wrong. Is that 12? Oh, that was a 9, sorry. Interesting. Give me 1 second. Okay, I kind of suspected this. It turns out that the Desmos graphing calculator is in radians by default, and I didn't want to convert it, so I was getting the wrong answer. So watch, if I'm in radians and I do 9 divided by sine of 45, that's the answer we got, which wasn't the correct answer. We're looking for a 12.7. But if I go to degrees and do sine of 45, that's the answer that the textbook has. But it just, this further illustrates that, or further enforces that Desmos uses radians by default. Every software language, programming software language, uses radians by default. It's degrees go away. At some point, it's we won't see degrees anymore. But they're a little transition. We have a transition though. All right, on to the next. Pretty easy. Get under 20 minutes. I don't think it's gonna happen. All right, next one, 23. Here's my right angle. There's a 30-degree angle. I think that's 18. I can't read it. 18, and here's an x. And so which trig function uses the opposite and adjacent? That's going to be your tangent. So you're going to say tangent of 30 degrees is equal to opposite, which is x, divided by adjacent, which is 18. So x is equal to 18 times tangent of 30 degrees. Perfect answer. I love this answer. The textbook has an answer of approximate answer of 10.4. 25. Okay, now we're like kind of making some, going faster, which I like. 25 looks like this. This is 32 degrees. This is x. This is 14. Feels the same. Going with tangent. Tangent of 32 degrees is equal to x over 14. So x is equal to 14 times tangent of 32 degrees. Whatever. No big deal. On to next. 27. Refer to the beginning of the lesson and the figure in the right. What the hell? Oh, got it. Find the altitude of a person parasailing. If the tow rope is 250 meters long and the angle is 32. I mean, this isn't very interesting because they give you everything. So they actually give you the triangle. So this is 27. Like the hard part about word problems is like making the triangle, like trying to figure out what angle is where. All right, this is 32 degrees. This is 250 feet, which is the rope. And we're trying to find the person's altitude, how high the person's up. And that kind of makes sense. Like you can calculate the length of the rope, or usually know the length of the rope is, and you can find the angle of elevation. So now we can figure out how tall the person is in the air, or how far up. This is opposite. This is hypotenuse. So this is a sine function. So sine of 30 degrees is equal to opposite, which is a, over 250. So we get a is equal to 250 times sine of 30 degrees. Yeah. Oh, 32 degrees, not 30 degrees. 32. Perfect. Plug that into your calculator, or I feel like this is a very acceptable answer. And we're done. Moving on to 29. Come on, 20 minutes. Less than 20 minutes. We got this. 29 looks like this. There's x. Here's 10. Here's 5. What two sides are we using? We're using the opposite and the hypotenuse. So that's sine of x is equal to opposite over hypotenuse, 5/10. I want to get rid of the sine, so I'm going to take the sine inverse of both sides. So sine inverse of sine of x is equal to sine inverse of 5/10. A function composed with its inverse will just yield x. And we get x is equal to sine inverse of 5/10. And this I actually know. It actually comes from a unit circle. This will be 30 degrees. All right, on to 31. Oh, we're getting close. And there's a word problem. 31. Yeah. Right angle, 9, 12, and x. All right, so what trig function uses the opposite and adjacent? That's tangent. So you get tangent of x is equal to 9/12. So you'll get x is equal to tangent inverse of 9/12. So you can reduce that, maybe 3/4. Yeah, 3/4. That is not a unit circle. All right, on to the next. We are officially on 33, but I feel like we're going really fast at this point. Right angle, 32, 27. I'm just glad we don't have to find the third side. I was like, it was okay. We have the adjacent side and the hypotenuse. So that's going to be cosine of x is the adjacent side to hypotenuse. And so therefore x is equal to cosine inverse of 27/32. I know I can't make parentheses. On to 35. 35. Squirrels. Love squirrels. Adult flying squirrels, oh, even better, can make glides up to 160 feet. If a flying squirrel glides horizontal distance of 160 feet and an angle of descent is 9 degrees, find the height. Find its change in height. Okay. All right, so we got a flying squirrel, and it's like, its horizontal distance is 160 feet. I think that's what it said. Yep, horizontal distance 160 feet. Its angle of descent is 9 degrees. Okay, so I have like this right triangle, and then it says if flying a squirrel, horizontal distance, angle of descent, find its change in height. So we want to find how far it went down, I guess, in the y value. So I guess I'll call this maybe y or something. So what trig function uses opposite and adjacent? That's tangent again. Tangent 9 degrees is equal to y over 160. So y is equal to 160 times tangent of 9 degrees. Turns out to be 25.3. Whatever's. On to the last problem. We're over the 20 minutes, kind of a bummer. I probably shouldn't have told some 2-minute story at the beginning, but it is what it is. 37. Don't know what's going on. Oh, I like this. And I want to show you can do this without a calculator, I promise. Here we go. We have 46.5 degrees. Perfect. And we have 30.2. Actually, this is no big deal. Let's pick one of the variables first. Let's go for y. Y would use the adjacent over hypotenuse. So we'd use cosine of 46.5 is equal to y over 30.2. This is very interesting. I thought it was a different type of problem. So you get y is equal to 30.2 times cosine of 46.5. On x would be the opposite. So you'd say sine of 30.2. It's like, that's not very interesting. That's going to be, sine of the angle, which is 46.5. You get x over 30.2. So x is equal to 30.2 times sine of 46.5. I love these answers. Done. 25 minutes. That's okay.